We have this at Mega 16 microcontroller, and we are getting PWM on the Osio not pin of the microcontroller. The speed of a DC motor depends on the duty cycle. So if you want to increase speed, we have to increase the duty cycle, and if you want to decrease the speed, you have to decrease the duty cycle. So the speed is a function of duty cycle. So basically what we are doing, we are changing the average voltage of the square waveform by changing the duty cycle. So if we make this kind of signal, so we'll get 100% speed, and if we provide a low signal, then the motor will be stopped, and the speed can be vary from 0 to 100% by making t on from 0 to 100%. So for timer 0 of Atmega 16 microcontroller, we can change duty cycle by configuring the OC on out resistor. So the minimum value will be 0. So in this case, we'll get a constant 0 low signal, and the maximum value will be 255. So corresponding to this value, we'll get the maximum speed, and the speed will be 0, or we can say the minimum speed. So next understand the connection diagram. So we have PWM available on the OC not pin, and to drive the motor, we need a motor driver IC L293D. The driver IC L293D can drive two DC motors. So we have two inputs, IN1 and IN2, and one enable input. Then we have ground and VCC to drive this IC, to provide supply to this IC, which is usually 5 volt, and the second supply is for the motor. So this supply Vs uh, will have to be provided as per the motor rating. So for example, if you want to drive a 12 volt DC motor, this should be connected to a 12 volt supply. Okay. Now the OC not pin. So there are different ways in which we can connect these pins to the microcontroller. So one way of doing this, you can connect OC not to enable signal, and then we can connect I1, IN1, and IN2 to two GPIO pins. So let's take PA naught and PA1. Okay, or we can make enable high, or OC not can be connected to one of these input pins. And then we can vary the duty cycle to change the speed. So to run in this direction, this will be 1 and this will be 0. If you want to change the direction, this should be 1 and this should be 0. So we have to write a program to generate PWM, and once you generate PWM, just connect OC not pin to the enable signal, or IN1 or IN2. This is the Proteus simulation in which we are controlling a DC motor of the 5 volt DC motor, and we have connected OC or not, or PB3 to IN1.